Welcome to AI Podcast. I'm Ethan, and today we're digging into a fresh EMNLP paper called Coarse-to-Fine Grounded Memory for LLM Agent Planning.
The title's a mouthful, but the idea's pretty clean, right?
Exactly, short version. The authors show that if you structure an agent's memory in 3 layers, from big picture down to fine details, the agent plans better and recovers from mistakes more reliably across standard benchmarks.
So before we unpack those layers, who's behind this?
Lead author Yang with Hongming Zhang, and the team is from the Institute of Automation at the Chinese Academy of Sciences.
Got it. Now what problem are they tackling because agents already store memories of past runs?
They do, but most systems lean on a single flavor of memory, like one kind of reflection or one type of saved experience, and that's brittle. If your stored experiences are mediocre, the guidance you extract is also mediocre, and agents tend to wander during exploration or derail when information is missing.
Right. Like giving a traveler only a pile of ticket stubs and expecting them to navigate a new city.
Perfect analogy, this paper says. Let's ground memory at 3 levels so the agent always has a map, some travel tips, and a quick cockpit check before each move.
Okay, walk me through those 3, starting with the map.
Layer 1 is coarse-grained focus points. Before they collect any experiences, the model uses its own world knowledge to sketch what matters in a task. Those focus points guide exploration, so the offline experience pool is higher quality and more varied.
So instead of wandering the city, the agent says, "These are the neighborhoods worth visiting. Let's start there."
Exactly. Layer 2 is hybrid-grained tips. Once they have trajectories from both successes and failures, the model distills lessons into a tips dictionary. Some tips are broad, like principles that transfer to similar tasks. Others are specific, like how to handle a quirky website button.
That sounds like a stack of index cards, some labeled general rules, some labeled in case of weird checkout flow, do this.
Yep, and the third layer is fine-grained key information reflection. During inference, the agent retrieves a few relevant experiences and tips, but if it detects an anomaly, it pauses, pulls out the key facts of the current state, and runs a short self-Q&A to fix its plan.
Like a pilot running a quick instrument check when turbulence hits, not a full manual, just the essential indicators.
Exactly, and that small, grounded self-check is what keeps the plan from drifting.
How did they test all this?
3 interactive benchmarks: household tasks in AlfWorld, online shopping in WebShop, and simple science procedures in ScienceWorld. Success rate is the main metric, and to keep comparisons fair, they ran strong baselines and used similar large models across methods, often a GPT-4 turbo policy with a separate model to extract knowledge and tips.
So apples to apples as much as possible, what did they compare against?
React for reasoning plus acting, XBL for experience recall with insight extraction, AutoGuide for guideline generation, and QBE for fixed question reflection. The new method consistently beat them.
Can we quantify that without putting listeners to sleep?
Yes. Think double-digit gains across the board, roughly a bit over 10 points on the household tasks, around 20 on the shopping site, and close to 30 on the science tasks, which is pretty striking.
That's a lot for mature benchmarks. Any sense of why the lift is so big?
2 reasons. First, the focus points make the collected experiences better from the start. Less noise, more signal. Second, the hybrid tips and that fine-grained self-Q&A reduce derailments when the environment does something unexpected.
Did they run ablations to prove each piece matters?
They did. Add any single module and you see a bump, stack all 3 and you get the best numbers. And if you remove focus points from the full system, performance drops, which suggests the quality of the experience pool is a real bottleneck that they're easing.
I'm curious about retrieval. How many past experiences did they grab to form those tips?
Nice detail there. Using just a few top matches worked best, 2 or 3. When they pulled in 5, performance actually dipped. Too many semi-relevant tips start to conflict, so moderation beats maximal recall.
Less is more. Pick your advisors carefully.
Exactly.
What about generalization? Does this only work on the exact environments they trained on?
They tried transferring tips from web shop to a different shopping environment and still beat the baselines, so the distilled advice wasn't overfit. And they also swapped the base language model. From smaller open-source models up to GPT-4 class, the approach kept its edge.
Sounds practical, but I'm going to put on my skeptic hat. Reproducibility, cost, any flags?
Fair concerns. The experiments rely heavily on closed-source models, and there wasn't a public code release listed in the paper materials. They do report compute and settings, but folks who want to exactly replicate might struggle. Also, building that offline experience pool requires a lot of API calls. The focus points make it more efficient, but cost will matter in real deployments. And last, the method is sensitive to how many items you retrieve, so production systems may need adaptive retrieval to avoid flooding the prompt with noisy tips.
And on the safety side, reflection that edits plans mid-flight is powerful, but you'd want guardrails if the agent is acting on real systems.
Totally. A risk and governance section would be a helpful addition in future versions.
All right, what's the one-sentence takeaway for a team building agents today?
Give your agent a map, pack a small set of reusable travel tips, and before each critical move, do a quick grounded instrument check.
Nice. And if someone wants to try this at home, any immediate suggestions?
Start by generating focus points from the task description before you ever collect data. Then distill tips from both successes and failures, not just the wins. And finally, implement a short self-Q&A that extracts the key facts of the current step before you let the agent change course.
Right, and keep retrieval small and relevant. 2 or 3 trusted precedents, not a whole crowd.
Exactly. And if you're cost-sensitive, try swapping in a strong open-source model for tip extraction and see how the trade-off looks.
Okay, final word, what impressed you most here?
Honestly, the simplicity, it's not a giant new architecture. It's a disciplined way to ground memory at the right granularity, and the results show up immediately.
I like that. Structure beats brute force, all right? That's Coarse-to-Fine grounded memory for LLM agent planning by Yang, Hongming, Zhang, and colleagues. Thanks for listening.
This was AI Podcast. If you found this useful, share it with a teammate, and we'll see you next time.